Here we have a SAT math problem. Okay, let's go to the question. In triangle ABC, angle C is a right angle. Point D lies on AB, point E lies on BC, and D is parallel to AC. If the length of AB is 39 units, D is 8 units, the length of AC is greater than the length of BC, and the area of the triangle ABC is 270 square units. What is the length of B in units? Okay, in the given triangle, since angle C is a right angle, ABC must be a right triangle. Okay, let me draw a right triangle. Here I have drawn a right triangle. Since C is a right angle, let me mark C over here at where we have right angle, and let me mark point A over here and B over here. There is an information that point D lies on AB. Okay, now let me mark the point D at somewhere on the line segment AB. This is point D. Point E lies on BC. Now let me mark the point E at somewhere else on the line segment BC over here. And D is parallel to AC. Okay, now let me connect the 2 points D and E over here. And there is an information that this line segment DE is parallel to AC over here. The length of AB is 39 units. Okay, here I have the line segment AB. Its length is 39 units. And D is 8 units. D is over here. Its length is 8 units. The length of AC is greater than the length of BC. And the area of the triangle ABC over here is 270 square units. What is the length of BE in units? We have to get the length of this line segment BE over here. Okay, now let me assume the length of the line segment BE is X. Okay, now my aim is to get the value of X, which represents the length of BE. And also, let me assume the length of the line segment AC as a lowercase a, and the length of the line segment BC over here as a lowercase b. Now let's consider the two parallel line segments over here, DE and AC. Now these two parallel line segments are intersected by another two line segments. One is AB over here and other one is BC over here. Whenever two parallel line segments are intersected by the third line segment, then it is called a transversal. Okay, here this line segment AB is transversal, this line segment BC is also transversal, and the angle over here and the angle over here are called corresponding angles, and they are equal in measure. And since BC is transversal, the angle over here are called corresponding angles, and they must be equal in measure. Already we know that the angle over here is a right angle, then we'll have right angle over here. The two interior angles of the bigger right triangle ABC are equal to the two interior angles of the smaller right triangle DBE. By angle similarity postulate, the two triangles, the bigger right triangle ABC, the smaller right triangle DBE are similar. We can use the similarity of two triangles and get the length of the line segment B, that is given by X. For that, we have to know the value of this lowercase a, that is the length of this line segment AC, and the value of the lowercase b, that is the length of the line segment BC. Okay, now let's plan to get the values of lowercase a and lowercase b. For that, we can consider the information we have over here. That is the area of the triangle ABC is 270 square units. Now let me write the stuff over here. Area of triangle ABC equals to 270 square units. And we know the formula for area of a triangle, that is base multiplied by height divided by 2. On the right side, we can write 270 as it is. Okay, in this right triangle ABC, this AB represents the hypotenuse of the triangle because it is opposite to the right angle. In the remaining two legs AC and BC, we can consider one of the legs as the base of the triangle and the other leg as the height of the triangle. We can consider this leg AC as the base of the triangle and this leg BC as the height of the triangle. Okay, the base of the triangle is a lowercase a and the height of the triangle is a lowercase b. Let's plug in over here. Then we get a times b divided by 2 equals to 270. Now let's multiply both sides of this equation by 2 to get rid of the denominator 2 on the left side over here. On the left side, this 2 will cancel out. We get a times b equals to 270 times 2 is 540. Okay, here I got the value of a times b. Since ABC is a right triangle, we can apply Pythagorean theorem in this right triangle. According to Pythagorean theorem, sum of the squares of two legs of the triangle is equal to the square of the hypotenuse. We know that this lowercase a and lowercase b represents the lengths of the two legs AC and BC, and the length of the hypotenuse is 39. Okay, now let me square this one and add, that is a square positive b square. this is equal to, that is a sum of the squares of two legs equals to square of the hypotenuse. So that is 39 square. A square positive B square equals to the value of 39 square is 1521. Okay, now let me consider an algebraic identity, that is a square of a binomial, that is a positive b the whole square. Its expansion is a square positive b square positive 2ab. Okay, a positive b the whole square equals to, we know the value of a square positive b square, that is 1521. Let me write over here. And positive 2 times, already we got the value of a times b, that is 540. Let me plug in over here. Okay, a positive b the whole square equals to 1521 positive 1080. A positive b the whole square equals to, now let me add 1521 positive 1080. I am getting 2601. Okay, now to get rid of the exponent 2 over here, let me take a square root on both sides of this equation. And here on the left side, the square root and square will cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out. And for the other square root, we'll consider positive or negative sign. Okay, here on the left side, we have a positive b. A and b are the lengths of the two legs of the triangle. When I add the lengths of the two legs of the triangle, it cannot be negative. So we don't have to consider positive or negative sign over here. We can consider only positive sign for this value. And let me get the square root of 2601, that is 51. We get a positive b equals to 51. And I consider this is equation number 1. Now, let me consider another identity, that is a negative b the whole square equals to a square positive b square negative 2ab. Okay, here a negative b the whole square equals to, for this one we know the value, that is 1521. Negative 2 times the value of a times b is 540. Okay, a negative b the whole square equals to 1521. Negative 2 times 540 is 1080. And a negative b the whole square equals to, when I simplify this one, I am getting 441. Now to get rid of the exponent 2, we have to take square root on both sides. Okay, when I take square root on both sides, the square root on the left side and square over here will cancel out. I am getting a negative b. And here, can we consider positive or negative sign over here? No, I consider only positive sign for this square root, and square root of 441 is 21. Why can't we consider positive or negative sign for this one? Because on the left side we have a negative b. We know that the length of AC is greater than the length of BC. That is, the value of this lowercase a is greater than the value of this lowercase b. And both a and b are positive values because both of them are lengths of the two legs of the triangle. Okay, here we subtract the smaller positive value b from the larger positive value a. So definitely it cannot be negative. So I consider only positive sign for this square root. Then I got the equation a negative b equals to 21. And I consider this is equation number 2. Now we have to solve these two equations for a and b. Okay, now let me erase the stuff and continue the problem. Let's solve these two equations. Let me add the two equations 1 and 2. Okay, a positive b equals to 51. A negative b equals to 21. Okay, here when I add these two equations, this positive b, negative b will cancel out. When I combine a and a, I'm getting 2a on the left side. When I combine positive 51 and positive 21, I'm getting positive 72. Let me divide both sides of this equation by 2. Then this 2 will cancel out. I'm getting a equals to 36. Okay, now let me plug in this value 36 for a in one of these two equations to solve for b. Okay, now let me plug in into the first equation. Then we get 36 positive b equals to 51. Let me subtract 36 from both sides of this equation. Then this one will cancel. B equals to, when I simplify this one, I am getting 15. Okay, here I got the values of the lowercase a and lowercase b. Now let me replace them with their values. The value of a is 36 and the value of lowercase b is 15. Okay, already we have discussed that is the two interior angles of the bigger right triangle ABC are equal to the two interior angles of the smaller right triangle DBE. By angle similarity postulate, the two triangles are similar. So the ratios of the corresponding sides must be equal. Now let me consider the side B in the smaller triangle, because for that one we have to find the length. Okay, now let me take the side BE in the smaller right triangle. The corresponding side in the bigger right triangle is BC. Let me take it over here. So this is the ratio of one pair of corresponding sides. Now, let me consider the side DE in the smaller right triangle. Okay, the corresponding side in the bigger right triangle is a AC. Let me take it over here. This is the ratio of another pair of corresponding sides. Since the two triangles are similar, the ratios of the corresponding sides must be equal. That is, the corresponding sides are proportional. Okay, for B, we know that X, let's plug in X for B. And for BC, we know that 15. And for DE, we know that 8. And for AC, we have 36. Okay, here for 8 and 36, there is a greatest common divisor 4. There is 4 goes into 8 2 times and 4 goes into 36 and 9 times. I am getting x over 15 equals to 2 over 9. Now let me multiply both sides of this equation by 15 to solve for x. Okay, this 15 will cancel out, and here there is a common divisor for 9 and 15, that is 3. 3 goes into 9 3 times and 3 goes into 15 5 times. Okay, we get x equals to 2 times of 5 is 10, 10 over 3. Okay, here I got the length of BE, that is 10 over 3 units.